These videos are for November 9th, November 13th. We're looking at applying trigonometric identities to simplify expressions. Go through a few of these and then I'll post solutions online. But if you don't have the notes from last class, this really isn't going to make sense. So I would highly recommend taking those out. Or the last video, or whatever. You're going to need those identities in front of you, or else this won't make too much sense. So I'm going to try to walk through it. I'm going to try to talk about it. But if you don't have those pause, find those identities, and you go back and watch the previous video so you have those notes, please do that. But let's get started. So the idea is that we can use the fundamental identities. If you've been in class, all those identities on the board that we keep talking about, to simplify these expressions. So here, for example, there's an even-odd identity that says cotangent of negative x. I can replace that with negative cotangent x because those are equal. So that's something that we can do here. And that's fine. That's completely okay. Let's keep this as secant. Okay. Now, there's probably a lot of different roads we can go on, but some people said two main roads that we went on. One is let's change cotangent into 1 over tangent using the reciprocal identities, and let's turn secant into 1 over cosine using the reciprocal identities as well. We can multiply these two fractions. If I multiply straight across, we would get negative 1 over tangent x cosine x. And then a lot of students said, well, that's kind of like a roadblock. I don't know where to go from there. And so they stopped. And that's okay. Everything here is mathematically equivalent, but it's not helping us simplify. It might not help us simplify. So instead, maybe we keep secant as 1 over cosine, but change cotangent. Hopefully we know that cotangent is cosine over sine, so we can replace that. So two things we'll need to know is that tangent is sine over cosine. These are not on the board, but definitely things that we will need to know. Okay. Now what we can do is multiply straight across and get negative cosine x over sine x cosine x. The cosines now would divide out. We would be left with negative 1 over sine x. However, we can look at the reciprocal identities and see that 1 over sine x is cosecant x. And so because 1 over sine x is cosecant x, with that negative, this becomes negative cosecant of x. And so we've simplified it down to just one singular trigonometric function using the identities. Okay, so a few key things here. First, this road, this route here, everything is correct, but it might not have helped us simplify. So if that's the case, we need to go back to the drawing board. Here, we changed this to cosine over sine, 1 over cosine. We saw that the cosines divided out, and which would left us to negative 1 over sine, which is negative cosecant. Okay, that's the idea, is that we might turn it to 1 over tangent, we might turn it to 1 over cosine, we might not, but we want to put these trig functions into similar expressions, equivalent expressions that help us simplify. Okay, let's talk about the next one. Here, when we talked about this in class, some students said, well, I know that using the reciprocal identities can be 1 over sine. Using the reciprocal identities, that would be 1 over secant. And then if I multiply across, 1 times 1 is 1. Sine times secant is just sine times secant. But they didn't know where to go from there. Again, they hit a roadblock similar to what's here. So Let's call that a roadblock. And maybe let's change cosecant. So we have to go back to the drawing board. See things that we recognize. Maybe change cosecant into 1 over sine. Cosine, we don't necessarily have to change everything. So maybe keep cosine as cosine. Maybe put that over 1. And then 1 times cosine would be cosine. Sine times 1 is sine. And then cosine over sine would be cotangent. Okay, so again, it's a matter of what tools, those fundamental trigonometric identities that hopefully you either have in front of you or you can recall them somehow. We need to use those identities in a way to switch. Cosecant is same thing. It is equal. It is equivalent to 1 over sine. So I can replace cosecant with 1 over sine. I could replace cosine with 1 over secant. However, that's not helpful in simplifying. So we stop there and consider maybe we leave cosine as just cosine, which helped us simplify. Now, a strategy that I mentioned in class that is helpful, notice tangent is sine over cosine. Cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. So all 6 trig functions we can write in terms of sine and cosine. So that might be beneficial to write everything in terms of sine and cosine. I'm going to skip this one, put that solution online. Let's talk about this one. So here we have cosine squared. Maybe leave that. We don't need to change it. So maybe we change tangent. We already have cosine squared. What do we know about tangent in terms of sine and cosine? Well, we know that tangent is sine over cosine. Let's keep that as cosine squared. So now maybe we put this over 1, multiply straight across. We get cosine squared times sine over cosine. And then if it helps you see it, cosine squared, if we're squaring anything, we're multiplying that by itself. So we could write this as cosine times sine. And now the cosines, one of these would divide out with that one, and we would be left with cosine x times sine x. If we look back to the drawing board, back to our identities, nothing really we can replace with cosine and sine to help us simplify. So that would be in its most simplified form. Okay. So maybe turning things in terms of sine and cosine isn't always going to be helpful. You need to make a note of that. That is not a strategy that is always going to be helpful. However, it is a strategy that will be helpful and maybe a good place to start if you don't know where to start. So I would recommend, especially with these more, what I'm going to call more basic, more simplistic trigonometric identities or expressions, maybe turn sine and cosine, help simplify. We'll talk about other strategies as we continue simplifying these expressions. And as we do, hopefully you build the skills, the instincts to notice when do I change what to help simplify. I'm going to stop this video here. I'll post the solutions online. If you have questions, which I know you will, it's a very different concept, a very different skill set. Please ask me. I'd love to answer those questions. We'll have a lot of time in class to work on these as well.